Hello world! In today's video, we're going to take a look at Angular signals in Angular version 17. Welcome to Web Dev Frontiers. My name is Tamas and I'm here to share my experience with you in web technologies. The first question you're probably wondering about is, what are signals? So while signals in Angular are a new thing, they have been around for quite a while in other programming language in one shape or another. But effectively what a signal is a way for you to track if the value of a variable changes. So for example, we could set up a signal to track a counter, and every time when we update that counter programmatically from within our Angular application, the UI or everywhere else where you are referencing that counter is going to be updated automatically by the framework itself. And that has a lot of interesting use cases. So in this video, we're going to take a look at a very simple use case where I'm going to set up a signal. We will actually implement this increment function, and then we're going to take a look at a little bit more elaborate example where I'm also going to shed some light on the difference between RxJS and the subscription versus when to use Angular signals. Before we get started, just to let you know, an Angular signal can take any value. So it can be a primitive, so it could be a very simple thing as a number or as a string, but it can also work with very complex data structures and objects as well. Now, I've already set up the boilerplate Angular application by using the ng-new command. And if you want to do this on your machine as well, please make sure that you're running Angular version 17. So just please double check that. And I created a couple of things that we're going to be using later on. You can see I've created a service. At the moment it's empty, so you don't need to worry about this for now. We're going to write that together. And I have a component, and I've uploaded just two images into the assets folder. Again, we're going to take a look at those at a later point in time. But for now, let's put together a very simple example. I already have app.component.ts open here, and all I'm going to do now is come to the class and just create a class member. So let's call that counter, and I'm going to make that equal to signal. And notice that this gets auto-imported from @angular/core, and I'm just going to set the signal with a value of 0. So effectively counter will have a value of 0. Then I'm also going to write an increment function. And inside this increment function, we're going to take the current value of the signal and keep on incrementing it by 1. Now, generally speaking, there are two ways to set a value for a signal. Option number one is that you call the set method on the signal, and that's going to set a given value and assign that value to the signal. If you want to keep on updating it, then I would recommend you use the update method, which is exactly what we're going to be using here. So I'm going to say this.counter.update. And when we use the update method, we can pass it a callback. And inside this callback, we're going to have access to the current value. And I want to return current plus 1. And that's pretty much it. So all we need to do now is, of course, go into our template and find a way to display the value of the signal. So let's just add an h1 here. And you would use the usual double curly brace syntax, and we would say counter, except this is going to be a writable signal, and we can't just use the counter keyword here because, as you can see, Angular already warns us that counter is a function and should be invoked. So if you're new to signals and you're used to the Angular syntax, just remember this, that you need to invoke signals as a function. Then under this, let's also add a button with a click event handler, and let's call the increment function here, and let's just call this button increment. Okay, that's it. So I already have this application running in my browser. So let's change to the browser itself. And there we go. So we get a big 0 and we get the increment button as well. So 0 is the current value of the signal. And if I click the button, then notice that the value keeps on increasing. And if I had this signal referenced in multiple places inside my application, the update would happen everywhere throughout the application. Let's take signals to the next level. In the example that we're going to be building together right now, we're going to basically keep on polling a REST API using an Angular service, and we're going to take the data that comes from that API via our custom service, and we're going to push that data to an Angular signal. And the data structure is going to be a lot more complex, and then we'll see how you can work with an actual RxJS subscription, how you can actually push that data to a signal, and how you can then use the signal to constantly keep on updating the UI. Now, the inspiration for this particular sample that we're going to be putting together right now comes from Eurosport. Eurosport is something that I've been watching. They're not sponsoring this video, by the way, if you're thinking, but I love Eurosport. I keep on watching it. I love sports. And I'm going to show you a screenshot of what I mean. They have a section of the website where you can watch live updates, but these live updates of various sports events happens via text. So basically every 30 seconds, the page would update and a piece of information from whatever sport it is that we're watching would come onto the screen. So if it's a football game, it would be something like a yellow card, a tackle, or a goal, and then the score would update, but it's all text-based. And so we're going to replicate that, although it's going to be a lot simpler and we're not going to implement the entire full system. But what we will have is a REST API that uses set timeout to constantly produce events for a made-up football game. Okay, so we're going to have this REST API, which will basically, every time when we call it, it's going to return an object, which is going to be either a goal, a red card, a yellow card, or a tackle. We're going to be polling this REST API from our Angular application, and as new pieces of data would come in, we're going to take that data and assign it to a signal, and we're going to then utilize the signal itself to update the UI to get this constantly refreshing screen with new events from a sports game. Okay, but this is all going to be static, of course. Now, how a system like this would work is that there would be a backend. Someone would type in what happens on the game, they would hit publish, that would be published to a server, and then of course the UI would then keep on polling that server, or maybe they use WebSockets as well, I'm not sure because I haven't looked into it, but you get the idea. We're going to create a much simpler version of that. Now, in fact, I do have the API, and this is just going to be using standard, Node.js HTTP module. I asked ChatGPT to give me Barcelona and Real Madrid players. So we're going to be mimicking the famous El Clasico game here. And of course, I know that these players are no longer in Barcelona, and the Real Madrid players are all wrong as well. But there you go, ChatGPT data is kind of old. And let's just test this API. So let's fire this up and let's do node and then just app.js. So there's an API that is running now on port 3000, and we need to go to /API/game, hit refresh, and there you go. So FC Barcelona in the first minute got a red card, and the player that got it is Sergio Roberto. Okay, this is all made up, obviously. Now, if I refresh this, then we get an action in the 4th minute, which is a goal by Barcelona. And you get the idea, so on and so forth. So we're going to get these random set of events at various intervals spit out by the REST API. The UI itself is going to be responsible for capturing these and displaying that in a nice way using a subscription and RxJS and the Angular HTTP module, as well as signals. All right, so let's start coding and let's see how this would work. The first thing that I would like to do is write the API caller service, and this is how it's going to look like. So I'm basically setting up an interval. Every 5 seconds, we're going to be calling this watch function, and of course, let's just make sure that we import everything that we need from here. And of course, we need interval as well from RxJS. We're going to take a URL, which I'm going to add later on. And then every 5 seconds, we're going to go out to that URL and we're going to be receiving some data from there. Okay, and notice the last bit here, which is called take while. Once the API is no longer producing data, so I think after the 94th minute, I've set up a rule that there should be, or after the 92nd minute, there should be no additional events generated by this API. So if we return a null from the API and if our service sees that, then it's just going to stop polling. Now, also notice that we have a red squiggly line for HTTP, and I thought I would show this to you as well because if you've written Angular before and you use modules, then you may not be aware on how to actually get the HTTP client working with standalone components and services. So what you need to do is go into app.config.ts, and where you see the providers list, all you need to do is type in provider and then find provide HTTP client, which will auto import from Angular Common HTTP. And you need to call this because this is a function. And there we go. Once you do that, then the HTTP client will be available throughout your application as well as inside your service once you have imported that as well. All right, so we have a watch function inside an API caller service that is going to be constantly polling, or rather every 5 seconds, poll our REST API. So let's actually put this into action. And to keep things simple, I've created already a score component and I added some CSS, and there's going to be different CSS bits and pieces, but more on that later. But let's go into the component TypeScript file to actually figure out the logic to do the polling and then use signals to display the data in the UI. Now, even before we get to the signal bit, I want to make sure that you follow best practices. Now, when you work with RxJS and you work with subscriptions, it makes sense to make sure that once the subscription is done or once the component is destroyed or you navigated away from the page, you unsubscribe from the subscription. So first we're going to see how to subscribe to it and then how to unsubscribe from this particular service. Okay, so what we're going to do first, we're going to create a private class member called API subscription. And this will have the type subscription, which will come from RxJS. Then I'm going to have two functions in here. One is going to be to subscribe and one is going to be to unsubscribe. And the logic for unsubscribe from API is going to be very simple. We just basically say if there is a subscription, then unsubscribe from it. But more importantly, let's take a look at how the subscribe to API function would look like. So this is how the boilerplate will look like, but let's now add the things that are missing, such as the API caller and of course the API URL. So the API URL is going to be relatively simple because that's just going to be the URL that we want to talk to, which is localhost 3000/API/game. So that's the easy bit. And of course, API caller is something that we're going to be adding via the constructor. So this is where we need to make sure that we will utilize the service. And inside the actual constructor, I will also want to make sure that I call the subscribe to API function that we just created. Okay, so this is starting to look good. So this is how you would do a standard subscription for an HTTP request inside Angular. So there's nothing extraordinary about this so far. If you've done Angular before, you may have seen something similar to this. If you haven't, well, now you know how to do this. Let's just fix this error here. That's going to get us an squiggly line, which I don't like. So I just add the question mark there. Okay, so the boilerplate looks good. So now the question is, how are we going to introduce signals to this? Well, based on the previous example where we had the counter and the increment, we basically created a signal with a default value. And so what we need to do now as well is create a signal where we're going to store what happens inside the game so that if the API returns some data, we can update the values inside the signal, and therefore our UI should technically also update. So let's actually do that right now. And I'm going to call this signal actions. We're going to set that to an empty array like so. Now, because I like to write proper TypeScript, let's just make sure that we add the appropriate types as well, because I know how an action is going to look like. I just told you that in the REST API, there's going to be a time, an event, there's going to be a player, and so we can actually create an interface for that and then use that for the signal as well. So we're not going to just say, hey, I want an actual array, but I want to make sure that this particular array adheres to the interface or the type that we're going to be creating. And I'm just going to do that right here as opposed to creating it as a separate file, but of course you can do that in a separate file as well. Okay, so this is how the interface looks like. So we have two options for the team. 4 options for the event type. The time is going to be a number and the player is going to be a string. So now we can actually tell the signal that this is going to be of action and is going to be an array of actions. And also, if you remember, inside the API caller service, I have a T here. So basically for the watch method, I can pass a type, and that type is then going to propagate down to the HTTP GET statement so that I know that the data that I'm going to get back will match that type. So we need to make sure that we're also going to be using that. So when we call watch, let's just also specify that this is going to return an action so that we get the right types throughout this particular score component TypeScript file. All right, and now comes the most important bit. We have data coming in, we have the signal, so we need to update the signal itself. And you already know that you can do this by using the update method. So inside this else statement, which basically says if data is still coming in, well, we need to say this.actions.update, and we need to find a way to somehow update the actions signal. Now, this time around is going to be a little bit different because before we just had a primitive, we just had a number, and we could take the previous value and add 1 to it. However, we are now working with an array, which is a more complex data structure. You would be probably inclined to say something like current and then say something like current.push and then just use the push method to add a new item to that array. But unfortunately, that will not work. So you need to use ES6 and you need to use the spread syntax to actually specify how the array will look like, or rather how the new array will look like. So what we're going to do is grab the current actions, and then what we're going to be returning is an array where the first item is the response, and the response, remember, is a response that comes back from the service itself, i.e. the data that comes back from the API. And we are going to be using the spread syntax to then add the rest of the actions that we already collected before. Now, first time around, current actions will be empty, so we're just going to get the response, but the second time around, we're going to get a new response, and then current actions will contain whatever we had in the array before. And so using this strategy, we can make sure that the signal will contain all the data that the REST API has sent to our service. Okay, so let's save this file and let's go to the template. And I already added some boilerplate code here because if you recall, I said I already had the CSS. So we're just going to have the 2 clubs and their crests on top. And then we have this div called actions. And this is where we're going to place all the actions that we're going to be having, essentially the data coming from the signal. So we're going to be using the for and the if control flows to display some of the actions. Let's start with the for one, right? Because the signal that we have called actions contains an array, so we need to iterate through that. So this is how the for loop would look like. And again, a kind reminder to make sure that when you reference the signal, you need to append the parentheses and make this a function call. Okay, so now I have access to the individual action objects. And so I can now print out whatever I want using just the general Angular syntax. So let's just add the paragraph for now. And let's just say action dot, and let's just maybe take a look at the player who does the action. Okay, so let's save this. And let's just make sure that we restart the API as well. Make sure that our Angular server is running. And before we test this, let's just go into roots and create a root definition for this. So let's add the path. Let's call this score, or let's call this game, and make sure that we load the score component right here, and then update app.component to add the router outlet like so. Okay, so let's go to the browser and see what we get. Okay, so we get a 00, we get the crests, and notice that in every 5 seconds or so, we're going to get a different player name. So that means that every 5 seconds, the API service is making a call to the REST API, and then the data that comes back from the service gets added to the signal, and because the signal gets updated, the UI automatically updates. So let's make this a little bit prettier and then see what else we can do. So let's go back to the editor. Let's go back to the template. And instead of just adding the player name, let's add some more complex logic in here. And this is how that more complex logic would look like. Even though it looks scary, it's very straightforward. Basically, for every event type, we're going to add a different class, and then we're just going to specify the time, whether it's a goal, by who, or whether that's a yellow card, a red card, or a tackle. And each of these paragraphs would have a different color based on the score component CSS file and the classes and the CSS rules that I have defined in there. So let's hit save. Let's go back to our UI and see what we get this time. Okay, so tackles are going to be blue, goals are going to be green, and of course yellow cards will be yellow and red cards would be red. Now, let's make this just a little bit more better so that we get some more practice with signals. Notice that as we're doing this recording, there are 2 goals already, but we still get the result as 0, 0. So the result doesn't update. Let's try to find a way so that every time when the action signal receives a goal, the score would actually update for the appropriate team. So let's go back to the editor and let's go back to the TypeScript file here, and we're going to need to add a new signal in here. And the reason why I do this is because I want you to understand that you can add any complex structure and use that as signals inside Angular. So let's add a signal called score and make this an actual object. And let's just say that FCB 0, that's Barcelona, and then Real Madrid 0. So this is going to be an object with 2 properties where the values are each set to be 0. And so what we need to do inside this particular logic here, inside the else statement, when new data points come in, is to make sure that if the event type is a goal, we update the score for the appropriate team. Okay, so we need to add an if-else statement in here, check the team, and then make the appropriate update to the property value inside the score signal. And this is how that code looks like. So notice that, first of all, I check if the event type is a goal. Then we check if the team is Barcelona or Madrid. So if it's Barcelona, then we use the update method and we only increment the FCB current value by 1. Otherwise, we increment Real Madrid's score by 1. So let's save this and let's go back to the template. And all we need to do here is just make sure that we are referencing the signal as opposed to using 0 and 0 here. So we can call score and just say dot, we need to call it as a function and then do dot FCB, and notice it auto completes. And then for this one, we need to do score and then dot, and then need to do RM like so. Okay, so let's hit save. Let's just make sure that we restart the API because probably it has finished spitting out all the data. All right, and let's go back to the browser and let's just see what we get now. So let's wait until the first goal. Hopefully that's going to come fairly soon. And we start right off with a goal. So there you go. Because there was a goal by Barcelona, we now increment that number by 1. And then the various events will come in and then we're going to have an end result. So I'm going to pause the recording right here and then I'm going to resume it when we are at the 92nd minute just to show you the entire set of events and, if you're curious, how this El Clasico played out. Well, I am truly sorry for Barcelona fans, but unfortunately Real Madrid has dominated this particular game. But jokes aside, if we look back, if I zoom out just a little bit, if we look back at all these events, you can see that the UI was constantly updated with all the actions that came in from the REST API. And then every time when there was a goal, and even the goalkeeper of Real Madrid scored, which is wow. I'm sorry, but yeah, so essentially every time there was a goal, the score also updated because we are utilizing a signal for that as well. Now, this application is really just a very simple demo. As I said, I'm using set timeout at the API level. I'm polling that API every 5 seconds, but you can think about it in a different way. Maybe you can do this as homework if you want. You could create some sort of an API that uses sockets. So every time when there's a new event or a new action that comes in via the API, Angular is able to get that information. And once you have that information, once you have that response from that API, either via service or any other way that you see fit, all you need to do is just update the signal and you will get an automatic update to your UI. And so essentially the difference between this is that inside a service where you use your subscriptions and your usual RxJS stuff in Angular, that bit is concerned more about the service layer of things, whereas signals make sure that the data that you want to display in the UI is going to be updated in every point where that particular data is being referenced. So that's more related to the UI side of things. So I'm hoping this explanation helps you to distinguish between when to actually use an RxJS subscription, for example, versus when to use signals in Angular applications. And that's it about signals in Angular 17. If you have any particular use case or if you are currently using signals, please let me know in the comments below. Also, do share your experiences with working with signals. Personally, I would love to know how you're using it in your current projects. If you found this video to be useful, then please give it a like, do subscribe for more such content, and I look forward to seeing you in the next one.